We will now examine how germ cells develop and can occasionally have problems resulting from abnormalities present in the chromosomes, either within the chromosomes or due to difficulty partitioning the chromosomes to the appropriate daughter cell. Now, given the way and the rapidity with which cells are dividing both in mitosis and meiosis, it's fairly amazing that we don't have more errors occur than we do. But generally, the process of mitosis and meiosis is very faithful and results in very few errors. However, errors do occur. And meiosis can cause chromosomal abnormalities in the daughter cells that are then used to produce new life, and that can lead to various problems. It's estimated that around 50% of all conceptions are lost, and 50% of those losses, so 25 overall, are lost due to chromosomal abnormalities in the germ cells. Chromosomal defects of some sort account for roughly 7% of all major birth deficits, with 8% being accounted for by the mutations of individual genes within those chromosomes. Now, any human cell is going to contain either 46 or 23 chromosomes, depending on whether it's a cell undergoing mitosis or a germ cell, which is going to be able to combine with another cell to create a diploid cell. The normal state of being for any cell is going to be euploidy, having 46 or 23 chromosomes. Any variation on that number creates a state called aneuploidy, and that can cause birth defects or spontaneous abortion if it's inherited in a germ cell. Here we can see an example where a nondisjunction event has occurred during meiosis 1, which leaves some daughter cells with no chromosomes and the resulting daughter cells on the opposite side having 2 copies of a single chromosome each. This aneuploidy can occur during a nondisjunction event at either meiosis 1 or 2 and tends to result in a chromosome with either too many or too few chromosomes of one type. In the end, we have either trisomy, where the affected individual will have 3 copies of a chromosome, or monosomy, 1 copy. Nondisjunction events, again, can occur at meiosis 1 or 2, but when these cells combine with another germ cell, we can have it proceed to a clinically detectable state as the embryo and fetus develops. Trisomy 21, most commonly known as Down syndrome, is the most common trisomy. If we take a look at the karyotype shown on the screen here, we can see that there are 3 copies of chromosome 21 present, when normally we'd expect there only to be 2. People with this condition have varying degrees of mental capacity, ranging from profoundly affected and unable to function to nearly full social function with some degree of accommodation. People with Down syndrome typically have delays in growth, some immune system delays, and flattened facial features, as well as what's known as an epicanthial fold over the top of the eye and a simian crease that goes all the way across the front of the palm. The risk of trisomy 21, and any nondisjunction event for that matter, increases with maternal age. So here at the bottom of the screen we can see 2 children who were born at the same time, twins, but the one on the right is displaying the typical appearance of someone with Down syndrome, particularly the epicanthial folds right over the eyes. Trisomy 18 is called Edwards syndrome, and it is the second most common trisomy. Infants with this are going to have several abnormalities: heart and kidney problems, omphalocele, where contents of the gut have herniated into the umbilical cord, micrognathia, small mouth, and microcephalic skulls, where the skull is actually smaller than we'd expect, sometimes as much as 2 to 3 standard deviations below the expected norm. The second and fifth fingers tend to overlap, which is very interesting and very distinctive for trisomy 18. And if you look at the picture, you can see how the second and fifth digits are wrapping over the top of digits 3 and 4. 80% of infants with this are going to pass away within a year, with 13% living to 10 years of age, so it does have a significant morbidity associated with it. Trisomy 13, or Patau syndrome, is another trisomy that is not as severe as others in that the affected individual can make it to birth, but children with this condition will have a variety of problems, including, again, heart and kidney deficiencies, cleft palate, holoprosencephaly, where there's failure of midline structures of the face to separate fully, sometimes causing cyclopia, single or fused eyes, and a proboscis on the forehead. They can also experience polydactyly with too many fingers, muscle weakness, and varying degrees of mental disability.